You ever wonder about the invisible rules that, make the entire internet work? Every single time you browse a website, stream a show, or send a message, your data is following this strict, kind of secret roadmap. So today, let's pull back the curtain on that exact roadmap, the OSI model.
I mean, it feels instant, doesn't it? You snap a picture of your cat, hit send, and boom, your friend is laughing at it seconds later. But in that tiny sliver of time, that simple photo file goes on this absolutely wild journey.
And that journey is guided by something called the Open Systems Interconnection model, or as everyone calls it, the OSI model. The best way to think about it is as a universal rulebook with 7 layers. Its whole job is to make sure that a computer made by one company can talk to a computer made by a totally different company. It's the standard that makes all this open communication possible.
Okay, so let's actually follow that photo on its trip. The whole thing kicks off at the very top of the model, in the layers that are closest to you, the user, and the app you're using. People often call these the software layers, and their only job is to get your data packed up and ready for the road.
First up, we have layer 7, the application layer. This is where your chat app says, okay, we're sending a photo, and picks a protocol, like HTTP if you were on a website, to handle it. Right below that, layer 6, the presentation layer, acts like a universal translator. It takes your photo, makes sure it's in a format the other end will understand, maybe compresses it to save time, and encrypts it for security. And then comes layer 5, the session layer. This one basically opens up a private phone line between the two devices, making sure that connection stays open and stable until the whole transfer is done.
So as your data moves down through these layers, something really important happens. Each layer wraps the data in its own little bit of information, called a header. This whole process has a name: encapsulation. The best analogy is putting a letter into an envelope, then putting that envelope inside a slightly bigger one, and then another one. Each new envelope has different instructions on it, meant for its matching layer on the receiving end.
All right, our data's all packed up. Now it's time to handle the logistics. The next couple of layers, these are the real workhorses. They act like a super efficient digital postal service, taking care of all the addressing and routing to make sure our package gets exactly where it needs to go.
First stop, layer 4, the transport layer. See, that photo of your cat might be too big to send in one go. So this layer's job is to chop it up into smaller, numbered pieces. It makes sending everything way more manageable, and it guarantees that all the pieces can be put back together in the right order on the other side.
And right here at this layer, a really important choice gets made. Do we use TCP or UDP? Think of TCP as sending a package with delivery confirmation and tracking. It's slower, but it meticulously checks that every single piece arrives and in the right order. It's perfect for things like web pages or file downloads where you need everything to be perfect. UDP, on the other hand, is all about speed. It just throws the data across the network as fast as possible and doesn't really worry if a few bits get dropped. This is what you want for a video call or online gaming, right? A tiny glitch is way better than a long buffering delay.
Next is layer 3, the network layer. This is where the big global address gets slapped on. Each of those little chunks of data gets a new wrapper, turning it into what we call a packet. And that wrapper has the source and destination IP addresses. This is the full street address that routers all over the world use to figure out the absolute best path for your data to take across the internet.
We're in the home stretch now, the final stage of the journey out. Our data has been prepped, chopped up, packaged, and addressed. All that's left is to actually send it. These last 2 layers handle that incredible leap from a digital idea into a physical reality.
At layer 2, the data link layer, our packet gets its very last wrapper, and now it's called a frame. This one's special because it contains the local address, the MAC address, for just the next hop on its journey, like your home's Wi-Fi router. And then, finally, we hit layer 1, the physical layer. This is where it all gets real. The frame is converted into a raw stream of ones and zeros and shot out as a physical signal. We're talking electrical pulses down a cable, flashes of light in a fiber optic line, or radio waves through the air.
And just like that, the photo is on its way. Now, once it gets to your friend's phone, this whole complicated process just happens in reverse. It's called decapsulation. The data travels back up the 7 layers, and each layer rips off its corresponding envelope until that photo is perfectly reassembled and pops up on their screen.
Okay, I know what you might be thinking. This all sounds super theoretical. But the OSI model isn't just an academic concept, it's an unbelievably practical tool, especially for the folks who have to figure out what's wrong when the network breaks.
So here's a really crucial distinction to make. While we all learn the 7-layer OSI model as this perfect blueprint,
The actual internet we use every day, it was built on a simpler 4-layer model called TCP/IP. See, TCP/IP won what they call the protocol wars because it was just more practical to implement. But, and this is a big but, the OSI model's detailed 7-layer structure makes it a way better tool for thinking through problems and troubleshooting.
And you don't have to take my word for it. Here's a quote from a sysadmin on Reddit who said that while they don't really think about every single layer day to day, they are constantly using layers 2, 3, and 7 to figure out what's broken. The OSI model basically becomes a mental checklist for them to hunt down the root of an issue.
You can actually map common problems directly to the layers. For example, is absolutely nothing working? Start at the bottom. Check layer 1. Is the cable even plugged in? Is it broken? What if 2 computers in the same office can't see each other? That sounds like a layer 2 problem, maybe a bad switch. Can't get to Google? That might be a layer 3 issue, like a bad route in a router somewhere. Can't access one specific website, but others are fine? That points to layer 4. Maybe a firewall is blocking the specific port that service uses. See, it's a really powerful way to narrow things down.
So with all this complexity, all these layers, all these things that can go wrong, where do you think most problems actually come from? Is it a faulty cable? A buggy piece of software? A misconfigured router?
Well, if you ask anyone who works in IT, they'll tell you the biggest issues, the ones that come up day after day, happen at a layer that isn't even on the official chart. They call it Layer 8.
As one Reddit user perfectly put it, it's almost always PPBKAC. That's a classic IT acronym, and it stands for Problem Exists Between Keyboard and Chair. Yep, Layer 8 is the human layer. It's kind of a running joke, but it's also a great reminder that no matter how complex our systems get, good old-fashioned human error is often the weakest link in the chain.
At the end of the day, the OSI model is so much more than just a technical diagram for network engineers. It's a powerful way of thinking. It teaches you how to take a process that seems impossibly complex and break it down into logical, manageable parts. And that really gets you thinking, doesn't it? What invisible frameworks, what secret roadmaps do you use to make sense of your own world?